Okay, Bismillah ar-Rahman ar-Rahim. So let's start with the today lecture, and I'm going to teach you the postulates of the quantum mechanics. And the presentation of the quantum mechanics actually begins with the stating the four postulates and elucidating their meanings. So this is the actually the standing of the quantum mechanics on the four postulates. So I am teaching at the near to the end of this course. So it would be better to understand what are these postulates, because we have already discussed in different lectures the standing of the all of these four postulates, and here I am just highlighting what are these and their importance and their meaning in the quantum mechanics. So the first one postulate is the for any possible state of a system, and here the state of the system is the quantum state. We are discussing the quantum state, and there is a function that is psi. Psi is the wave function of the coordinates of the part of the system, and the coordinates are the xyz and the time, and that completely describe the system. So this function should be everywhere, and you have learned that in all the with the Schrodinger wave equation, or with the solution of the Schrodinger wave equation, the kinetic energy or the momentum or the potential energy, we are using the psi. So the first postulate is there is the function psi of the coordinates of the part of the system, and here this is the one of the example is given over here. That means if a single particle whose position is described by the Cartesian coordinates, and these are the xyz coordinates, that means the particle is moving in any one of the direction or in the three direction xyz, and then the wave function can be written as like this. So the psi will be the psi into xyz. These are the coordinates of a system, and the time. So it may be time dependent or may be time independent. So here we are discussing the dependent of this wave function on the coordinates as well as the time. So let's suppose if there are the two particles, and then the coordinates of each particle must be specified. So the wave function requires two set of the coordinates as written over here. So one is describing for the particle 1, and 2 is describing the particle 2. So wave function would be the psi would be equal to the psi, and these are the coordinates of the particle 1 and the particle 2, and this is the time which is describing the movement or the movement of the particle in any one of the coordinates, that means in x, y, and z. So these actually this postulate making easier for us to how to express the movement of the particle in any one of the coordinates, or in all of these Cartesian coordinates. So that means we can express the particle on single particle and the two particle and so on. If there are the three particles, so you may add up x3, y3, and z3. So this is the way to represent the wave function with the coordinates of the part of the system. And in a generalized form, and if there are the multiple particles are there, then the wave function can be written in a generalized form, and here generalized coordinates are the qi. So where qi is written, that means it is already indicating that these are the coordinates, and these are the xyz coordinates, That means when Qi is written, the system is consisting the multiple particles. So instead of writing x1, y1, z1, then x2, y2, z2, x3, y3, z3, x4, y4, z4, it is actually the complicated system. So instead of writing the in detail, we will be using the Qi as a general form to represent the coordinates, and this is the way how can we write the wave function with the coordinates. And this model of the wave function is called the, of course, psi is called the wave function, and the state of the system that I describe is called the quantum state, as I have already explained before. Here we are discussing the system, this system of the state, or here the that is called the quantum state. So when Qi is written over here, that is it is understood that it is the quantum state, and which is representing with the psi, that is called the wave function. So this is the postulate one. I'm going to discuss more detail, and we have also discussed the psi square, that is the probability density, or in other way you can say this is the probability of finding the electron, and you can calculate by using the psi square. And here psi may be a complex, and the quantity that is of interest is, this is the size star, or multiply by psi. That means how can you get the psi square? That means you have to multiply 2 times the psi. So one is the psi and other one is the psi star. So that will give you the value of the psi square. So here, just to differentiate between these two, one is psi and the psi star. Psi star is the complex conjugate of the psi. So I am explaining over here what does it mean and how can be this postulate is helpful to represent the quantum state in a more easier form. So the complex conjugate of a function, that is this, is a function that is I replaced by the minus I, where the value of I would be equal to minus 1 under root. So this is actually the psi star. Here we are going to represent with the I, and the value of I would be equal to minus 1 under root. So this is just to represent this complex state in a more easier form. So how it is going to help us to understand the first postulate of the quantum mechanics? Let's suppose if one square of the function, and there may be any function, but here I'm going to discuss, let's suppose if the function is x plus ib, then what would be the result of this multiplication? And here that means one is the x plus ib, and the psi star and the psi would be equal to x plus ib. That means I'm going to multiply this with the same value, x plus ib, x plus ib. And here and let's conclude over here, the value of I would be equal to minus 1 under root. So here in this equation, if you open this equation, that means you have to multiply x with the x, that will be equal to x square, then x into ib, that would be ibx or xib, and it is written over here. And then you multiply with the again ib with the xib, that will be equal to ibx. That's why it is ibx will be equal to 2ibx. Then ib multiplied by ib, that will be equal to I square b square. That, and this is the actually the solution. This is a simple mathematical operation. That means a plus b multiplied by a plus b. So I have just opened this equation, And let's see, this is the solution of this equation. And what is the result? This is the x square plus 2ibx. Here I square will be equal to minus. How? Because I we are going to represent here, it is equal to minus 1 under root. So when you take the square of this one, 2 under root will be cancelled out, and what is left? Minus 1 is left. So you, when you multiply, or you can replace the I square with the minus 1, that would now become minus b square. So this is the result of the by placing the value of the I instead of the psi star over here, you would get the this form of the equation, but the resultant function is still complex. So however, if the function is x plus ib is multiplied by its conjugate base, and then conjugate mean it is the reverse of this one, x plus ib. Now we are going to multiply with the x minus ib. So what would be the result? And a similar way you can open like this we have discussed. First you have to multiply this x with the both one, and then ib with the both two values. So this would be x multiplied by x would be the x square, x multiplied by ib, that would be x ib. It is not written over here. Let me explain why it is not here. So when you multiply this ib with the x, this would be the again xib, and then ib minus ib, so that would be equal to minus I square b square. So one time you are going to multiply over here, this is the x square, then this is the multiply over here minus xib. When you multiply ib with the x, that would be the plus ib. So minus xib plus ib is going to cancel out, and that's why this is not written over here, because here one is the plus ibx and the other one is the minus ibx. So these are going to cancel out. So what is left? This is the solution of this equation, x square minus I square b square. Now again put the value of the I square. The value of I is minus 1, and when you take the square of this one, that again these are going to cancel out. What is left? Minus 1 is left. So minus multiplied by minus would be the plus, and b is coming from here. So this is the solution of this equation, and this is actually the there is no further function I is replacing over here. So that's why this is the right way to express the this function in a better way. And these by putting the value over here, you will get the final result of this one. So instead of repeating the I or the size star in the quantum mechanics, we just put the value of size star over here, and then get the final answer by putting the value of I, that would be equal to minus 1 under root. So this is all about the postulate 1 and how it make the quantum mechanics more easier to represent instead of writing a complex equation. So I have discussed over here both the psi and the psi square. So let's start with the